Today I am going to explain about polymorphism in Java. In Java, polymorphism means a very crucial role and it is one of the four pillars of object-oriented programming Java and one of the most powerful tools in a Java developer's toolkit. Now let us know what is polymorphism. The word polymorphism comes from Greek words poly means many and morphe means forms. In Java, it refers to the ability of a single object or method to take on different behaviors depending on the context. There are many benefits by learning polymorphism. The two main benefits are flexibility and reusability. Let us know what is flexibility. Flexibility means if we can write the code that adopts at different situations differently. And when it comes to reusability, it uses the same interface for different implementations. It means we can write anything at the same interface, but we can write in it different implementations. And polymorphism in real life. Think about a single person. They can play different roles depending on the situation. Same person can behave differently at different situations. We cannot know how can he behave. As a student, as an employee, as a sibling, he can perform like anyone. When it comes to student, he can attend classes, he can study subjects, he can write exams and complete assignments, etc. When it comes to an employee, he can do work, meets deadlines, collaborates with team and meetings, etc. As a sibling, supports family, shares responsibilities at time and play with children like etc. It means same person performing different roles. When it comes, it is exactly equal to polymorphism. Means a single person can perform different roles. It means it is known as polymorphism. Two types of polymorphism in Java. Java supports polymorphism in two distinct ways depending on when the method call is resolved. There are two types of polymorphism: compile time polymorphism, runtime polymorphism. When it comes to compile time polymorphism, compile time polymorphism is also known as method overloading. The compiler decides which method to call based on parameters. When it comes to runtime polymorphism, runtime polymorphism is also called as method overriding. The JVM decides at runtime which method to execute. Method overloading. There are four key rules we should follow while we are writing method overloading. Same method name, different parameter list, return type alone does not differentiate overloads resolved at compile time. It means method overloading can have same method name but with different parameters list such as type, count or order. Return type alone does not differentiate overloads resolved at compile time. The compiler matches the call to the correct method signature before the program even runs. When it comes to method overriding, the method overriding also has same four rules. It is having same method name and same parameters when compared to overloading. It is defined in a parent and child class. It requires inheritance and it is resolved at runtime. While we see method overloading, it is resolved at compile time and it does not require inheritance, but overriding requires inheritance and it is resolved at runtime. The child class provides its own version of a method already defined in the parent class. Let's just take an example. Here runtime in action. Animal object, new dog object or sound. It means reference type. Here the reference type is animal object declared as animal. Object type new dog, actually a dog at runtime. Output dog box, runtime decides. Why polymorphism matters? There are four main pillars of polymorphism, that is code reusability, flexibility, easy maintenance, dynamic behavior. When it comes to code reusability, we can write it once using many forms. That means if we write a code at one time and we can use it in many times in many different ways, it can reduces duplication across your code base. Flexibility, flexibility is very useful to swap out implementation without breaking the rest of your program. Easy maintenance. When it comes to easy maintenance, it changes in one class don't triple through the entire system. Dynamic behavior, Programs respond intelligently at runtime based on actual object types. Overloading versus overriding. We should know the differences between overloading and overriding. Overloading, it is based on static polymorphism. It is based on compile time. It can have same class name with different parameters. It is not based on inheritance, and it does not require inheritance. Overriding, when it comes to overriding, it is based on dynamic polymorphism. It is based on runtime, and it is defined at parent or child class. It is having same parameters, and it is inheritance required. It should contain inheritance, and it is required inheritance. The building blocks. Java achieves runtime polymorphism through two core mechanisms working together: inheritance, method overriding, and runtime resolution. These are the three main mechanisms working together. When it comes to inheritance, a child class inheritance from a parent, establishing an easier relationship and enabling method overriding. It means the relationship between child and parent class is easier relation. Method overriding, a subclass provides its own implementation of a method already defined in its parent class. Runtime resolution, the JVM determines which method body to execute based on the actual object, not the reference. Dynamic method dispatch. When a method is called on reference variable, the JVM resolves the call at runtime, not compile time. This mechanism is called dynamic method dispatch. It means the JVM resolves the call at runtime, but it not give the task until to resolved by compile time. This means dynamic method dispatch. Compile time, the compile time checks if the method exists on the reference type. No decision is made about which implementation runs. Compile time runs only if the method exists on the reference type. Other than that, it cannot execute the task. Runtime, the JVM inspects the actual object's class and invokes the correct overridden method. Object type versus reference type. The key distinction between object type versus reference type is the reference type determines which methods are accessible at compile time. The object type determines which method is executed at runtime. It means the reference types is used to determine which methods are accessible at compile time, but by using object type we can determine which method is executed at runtime also. This is the heart of runtime polymorphism. The JVM always follows the actual object. Let us know about differences between reference type and object type. There are three main differences between our reference type and object type. When it comes to reference type, it gives us the compile time definition. It controls accessible methods and it is declared in code language. Object type, it is a runtime reality. It controls which method executes, and actually it is used to actual class instance. Code in action. A single reference variable can point to different objects, each triggering its own behavior. It means a single reference variable is used to point different objects and it can trigger its own behavior. In the previous example, we have assumed animal as object is, and we can execute the object dog. Here also we can execute the object new cat. Object sound is also meow. The output we get is meow. Reference type is animal. The compiler only knows object is an animal. Object type is dog or cat. At runtime, the JVM calls the correct overridden method. When it comes to polymorphism with interfaces take runtime polymorphism further. A class can implement multiple interfaces, each defining a contract that the class fulfills with its own behavior. It means interfaces take runtime polymorphism further. A class can implement multiple interfaces, each defining a contract and class, and they can fulfill the class with their own behavior. Interface polymorphism in practice. Why interfaces excel? Interfaces decouple what an object does from how it does it. Any class implementing the interface can be swapped without changing client code. It means interfaces can decouple how does it looks and how does it works. In implementing the interface, we can swap out without changing client code. Other than without implementing interface, we cannot change the code without swapping. And there are three steps we have to follow, that is multiple inheritance of type, loose coupling between components, and easy to extend with new implementations. Rules of method overriding. There are four main rules that we should follow while writing method overriding. For a method to correctly override a parent method, it must follow strict rules enforced by the compiler. The four main strict rules are same method name, same parameters, requires inheritance, access level. Same when it comes to same method name, the overriding method must have exact name as the parent method. The name should be same, but there is no rule that the parameters should be same parameters. The parameter list must match exactly. No additions or changes should be done. If any additions or changes are there, the method overriding cannot be executed. Requires inheritance. It very much important in method overriding. The requires inheritance rules are very much important in overriding. Overriding only applies within an inheritance hierarchy. Extends or implements. The keywords in extends or implements. Access level, you cannot reduce the access level. Example, if in the previous action we have given protected and later we have changed it to private, it is invalid. We cannot change the access level. It is very useful to use @override notation to catch the signature mismatches at compile time. Real world applications, it means plays a very crucial role. Runtime polymorphism is the backbone of flexible, extensible software systems across industries. It plays a very crucial role in payment systems, vehicle system, and game development. When it comes to payment systems, there are so many types like UPI, credit card, and net banking. Here if we see UPI, credit card, and net banking share a payment interface. Each implements process payment differently. It means with UPI we can pay any online cash. With credit card we can debit or credit cash, and in net banking share a payment interface. Each implements process payment differently. When it comes to vehicle system, there are so many vast type of vehicles. They are car, bike, truck, all extended vehicle. They are overriding start and accelerate with unique logic. Game development, enemies, NPCs, and players share a character based class, each overriding move and attack. It means in game development, enemies, NPCs, and players all share a character based class. It is developed using polymorphism. These are the real world applications where polymorphism is perfectly used, and it is very important to know about this while we are learning about real world applications. Key takeaways. The four key takeaways of polymorphism are dynamic dispatch, override correctly, object type wins, interface enable flexibility. Runtime polymorphism gives Java its power, write code against abstraction, and let the JVM choose the right behavior at runtime. Master dynamic dispatch, respect overriding rules, and leverage interfaces to build systems that are clean, extensible, and maintainable. That means runtime polymorphism gives Java its power, write code against the abstractions, and let the JVM choose the right behavior at runtime. It allows the JVM to choose very good and right behavior at runtime. Master dynamic dispatch, respect overriding rules, and leverage interfaces to build systems that are clean, extensible, and maintainable. And let us know overall, let us conclude why it matters. Polymorphism makes software flexible and maintainable, whether it's a payment system handling UPI and credit cards via a single interface, or a game handling different types of NPCs. Polymorphism allows you to write code that responds intelligently to the actual object it encounters. Thus, let us know about the strict rules of overriding. Match the signature, access levels, use annotations. Thank you.